Today's lesson is on scientific notation. In your book, this is section 5-4. Alright, scientific notation is used when we write really small numbers or really big numbers. How we write scientific notation is we multiply a number that is 1 equal to or greater than 1 but less than 10, and we multiply it by a power of 10, so 10 to a certain power. So in this example, a is a number. It can be equal to 1 or greater but less than 10, and b is any exponent. And b just needs to be an integer. Alright, so let's try one. So when I have a really big number, like the one below, I go to where the decimal naturally is. Now every number naturally has a decimal. If it's not written, it's always to the right. Now I'm going to multiply this by a power of 10. The power of 10 that I'll be multiplying it by depends on how many places I'm moving my decimal. So I have to turn this number into a number between 1 and 10. So let's do it. Okay, so to turn this into a number between 1 and 10, I have to place the decimal between the 3 and the 7. So that's 12 jumps to the left. So when I multiply 3.78 or 3 78/100 times 10, it's going to be 10 to the 12th power. The number of jumps ends up being your exponent. Alright, now let me show you a decimal. The decimal's naturally on the left side. Now remember what I said, how do we show decimal amounts? Okay, a decimal amount's the same thing as a fractional amount. And how do we show that? That's right, we show them with negative exponents. So now we're going to take that decimal, and this time I'm moving to the right. To get it between 1 and 10, I have to place it between the 6. So that means I need to jump it 1, 2, 3, 4, 5, 6, 7 times. This time I'm going to write 6 4/10 times 10 to the negative 7th power. Now I wrote the negative 7th power because that was a decimal amount. And remember, negative exponents are really fractional and decimal amounts. So anytime you have a negative exponent, anytime you have a decimal, it will be a negative exponent. Anytime you have a negative exponent and you're multiplying it the other way, it will be a decimal amount. Alright, so let's do one together. Starting with your decimal, it's naturally to the right or to the left? That's right, it's to the right. Okay, so to turn this into a number between 1 and 10, I would have to move my decimal 3, 6, 7 times. So I'm multiplying 4 6/10 times 10 to the 7th power. Now you try the next one. Now check your work. Decimal's naturally to the right, so I'm going to move it 6, 9, 10, 11 times, so it's 6 2/10 times 10 to the 11th. Now we'll do one of the small numbers together. Start with your decimal. This time it goes, does it go between the 3 and the 8 or the 5 and the 3 to become a number between 1 and 10? That's right. It goes between the 5 and the 3. So I'm going to move it once, twice, 3 times, 4 times. And it's 5 and 38 hundredths times 10 to the negative 4th power. All right, now you try the next one. Now check your work. So this one becomes 4 times 10 to the negative 6th power. Now stop the recording and do the next 6 problems. Don't forget, if there's no decimal, it's to the right. Okay, now check your work. Number 1 was 6 and 3/10 times 10 to the 4th. Number 2, 7 and 245 thousandths times 10 to the 6th. Number 3, 5 times 10 to the 10th. Number 4, 8 and 7/10 times 10 to the negative 4th. Number 5, 6 and 53 hundredths times 10 to the negative 5 power. Number 6, 2 and 2 times 10 to the negative 7th power. All right, now we're going to go from standard form to, we're going to go from scientific notation to standard form. Standard form is the way we normally see numbers. So I start with 3 and 6/10, and this time, look at the exponent. The exponent depends which direction you're going to go on. So since this is a whole number, since this is a positive number, it means my amount is going to be a whole number. So to move my decimal in the whole direction, it would be to the right. So I'm moving it right 5 times. Place my decimal, and there we have the number. Then place your commas. Now if I have a negative exponent, I'm going to start with the original number. Remember, negative exponents are really decimal amounts. To keep this number as a decimal, I would have to move in this direction to the left. So now I'm going to move it 7 times. Place my decimal, and always start with a leading 0. In all the empty places, you're going to place a 0. Now stop the recording and do the next few practice problems through number 6. All right, now check your work. Let me go back, let you look at this. Check your work. All right, moving on. I'm not going to be covering using the scientific calculator. All right, so when I'm multiplying in scientific notation, I multiply number with number, number with number, like base with like base. That's it. Number with number, like base with like base. So I use my commutative property, multiply 1 and 5/10 times 2 and 1/10, and 10 to the 8th times 10 to the 6th. And that's where I get 3 and 15 hundredths times 10 to the 8th plus the 6th power, which simplifies to 10 to the 14th. All right, so now you try one. Actually, let's do this one together. This one's a little bit different. Now notice, once I multiply this out, our number, although it looks like in scientific notation, it's not, because this number right here, 19 and 142 thousandths, is not in scientific notation. That decimal needs to be right here between the 1 and the 9, needs to be a number between 1 and 10, less than 10. All right, so again, so if I have to make this smaller to balance it out, I'm going to have to make this one right here bigger. Okay? If this number right here gets bigger, this is going to have to get smaller to keep the scientific notation in balance. So if this gets smaller, this is going to have to, by 1 jump, this is going to have to increase by 1 power. So I get 1 and 9,142 ten thousandths times 10 to the 16th power. All right, I'll do the first one with you. Now, turn the recording off and do number 2, 3, and 4. Now check your work. Take a minute, look at the answers. 9.6 times 10 to the 25th. Number 2 is 1 and 176 thousandths times 10 to the 17th. Number 3 is 2 and 405 thousandths times 10 to the 19th. And 4 is 8 and 342 thousandths times 10 to the negative 10th. Dividing with scientific notation, we're basically doing the same thing we did with multiplying. We divide the like numbers and the like bases. So it's really two different problems. You do the division. And the one thing you have to think about is the answer you get. If this is not in scientific notation, you may have to convert it. So take a minute and try this one. You can use a calculator. All right, now check your work. Okay, our final answer is not, however, in scientific notation. So is 86 hundredths going to get smaller or bigger? It has to get bigger to be in scientific notation. So if this number gets bigger, then this has to get smaller by 1 power. And that would be 8 to the 11th power. 2 more for you to try. Stop the recording. Now check your work. And that's the lesson for today.